Friends, this is Pratyanshu. Today I discuss some interesting pattern. The first pattern or first property, there are there are 2n non-perfect there are 2n non-perfect square number between the squares of between the squares of the numbers between the squares of the numbers n and n plus 1. There are 2n non-perfect square numbers between the squares of the number n and n plus 1. Let's take example. If the value of n is 3, then n plus 1 value is 4. So now the square of 3 is 9 and the square of 4 is 16. If I find non-perfect square number between the 9 and 16, it is 10, 11, 12, 13, 14 and 15. So this is 1, 2, 3, 4, 5 and 6. So I find 6 non-perfect square number between two perfect square number. So if I apply the formula, there are 2n perfect square number and n is the smallest number. So n is 3. If I direct apply the formula, so 2n is the number, so and the value of n is 3, so 2 into 3 is equal to 6. So there are 6 non-perfect square number between 9 and 16. So if you find number of non-perfect square number between any two perfect square of number, any two squares of the number or any two perfect square, then apply this formula. Now second property or second pattern is adding odd numbers. So if a natural number, so we can say that if the sum of first n odd natural number is n square, we can say that in this form, or we take example. So I can say is the sum of first n natural numbers. Now I take sum of first 5 odd natural number. 5 odd natural numbers. So take 1 plus second odd natural 3, 5, 7 and 9. And the sum is 9, 7, 16, 5, 21, 3, 24, 1, 25. Because they are 5 numbers, then 25 is the square of 5. So it is also interesting pattern. If the sum of first n odd natural number is equal to n square. Now one more property. Sum of consecutive natural numbers. Sum of consecutive natural number. So we can say that a perfect square is always sum of conjugative natural number. If I take perfect square, like as if I take 5 square, which is equal to 25, is always 12 plus 30. Then every perfect square is expressed as sum of conjugative natural number. How to find these numbers? By formula. So the first number is n square minus 1 by 2, and second number is n square plus 1 by 2. In this example, the value of n is 5. So if I put 5, then 5 square minus 1 by 2, it is 25 minus 1 by 2, it is 24 by 2. So the first number is 12. And the second number, n square plus 1 by 2, it is 25 plus 1 by 2, it is 26 by 2, it is 13. So the second number is 13. So I again check with formula, applying the formula. Some more interesting pattern in next page. Now discuss product of two conjugative even or odd natural numbers. If I take for example 11 into 13, it can be expressed as 12 minus 1 and 12 plus 1, and this is the formula of a minus b into a plus b, which is equal to a square minus b square. So if apply this formula, then it is equal to 12 square minus 1. 12 square minus 1. Again similarly I take more example. Then 14 into 16 is equal to 15 square minus 1. So this is the fifth property. Now the sixth property is, if you find this type of number, if you find square of this type of number, like at 11 square, 111 square, 111 square, 11111 square, if you find these square number, then just a short trick, count the numbers for 1 and 2. Count the number 1 and 2. So take two odd numbers, 1 and 3. The second odd number is 3. Now written as this type, 1 2 1. This is the square of this number. In this 1 2 3, third odd number is 5. So written as like this, as 1 2 3, and reverse form 2 1, 1 2 3 2 1. So this is the square of this. 1 2 3 4, fourth odd number is 7. Now take 1 2 3 4 3 2 1. This is the perfect square of this number. Now if I take this square of this number, then 1 2 3 4 5, then 9. Then 1 2 3 4 5, 4 3 2 1. This is the square of this number. So this is the beautiful pattern. So I hope you understand all patterns. How I find all patterns. Now one more property, Pythagoras triplet. Pythagoras triplet. Pythagoras triplet. If I discuss, then for any natural number, like a m, and m is greater than 1, m is greater than 1, then always, then 2m m square minus 1 and m square plus 1 always form a Pythagoras triplet. Pythagoras triplet is like as three numbers like as 3, 4 and 5, like as 12, 13 and 15, like as this type, 12, 13 and 25. Now the triplet is 12, 13 and 15. This all forms Pythagoras triplet. Pythagoras triplet. Like if I take 3, 4, 5, then 5 square is equal to sum of 3 square plus 4 square. Those three numbers who follow this property is called Pythagoras triplet. It's called Pythagoras triplet. I take an example on Pythagoras triplet in next page. Find a Pythagoras triplet whose smallest number is 8. Let us first take smallest number m square minus 1 equal to 8. Solve this, m square equal to 9. So m equal to 3. So put the value, other two numbers is 2m and m square plus 1, which is 2 into 3, which is equal to 6, and 3 square plus 1, which is equal to 10. So 6, 8 and 10 follow Pythagoras triplet. But one problem, because in question, according to question, smallest number is 8. So this is the wrong triplet. Now I take 2m is the smallest number, which is equal to 8. The value of m is 4. Now put the value in m square minus 1 and m square plus 1. This is equal to 4 square minus 1, 16 minus 1 equal to 15, and 4 square plus 1, which is equal to 16 plus 1 equal to 17. Now the triplet is 8, 15 and 17, and whose smallest number is 8. So this is the required answer. So I hope you understand all the concept, all the interesting property of square number. So please download the Scholar Learning app, and if you already download this, then enjoy learning. Thanks to watching this video.